Hi guys, thanks for joining our course on the introduction of mud crab farming using vertical farming methods. My name is Yit and I will be your instructor for the course. My background is mainly in engineering, in chemical, mechanical and as well as petroleum. I've worked in oil and gas industries and now have chosen a full-time career in aquaculture. We run a farm in Malaysia and we have taught over 140 students year to date. So we are glad that you have made an effort to enroll in this course due to popular demand for an online platform. And hence we have recorded most of our sessions here on Udemy. So without further ado, I would like to start the main bulk of our lectures. So the goals of using RAS for aquaculture systems is to achieve what we aim for, which is indoor production systems. So RAS is a short form for recirculating aquaculture systems. The goal here is to produce more fish using less water and have more control over production. One of the major benefits of utilizing RAS for an indoor aquaculture production system is to achieve temperature control and to ensure biosecurity, isolating your products from infectious diseases and dangerous chemicals. RAS system has been practiced in many countries, mainly in the US as well as Norway, where they are used to farm high-value species such as rainbow trouts and the Atlantic sturgeon. So, how do we define a recirculating aquaculture system? By definition, an aquaculture production system that recycles and renovates the water for the culture of an aquatic organism. A simple way to define the amount of recirculation rate is a 95% recirculation rate. In other words, you indeed have to carry out some form of water change, and which can be up to 5 to 10%. Some useful conversions, so 1 meter cube of water is actually equivalent to 1000 liters, which is also about 1000 kilos.
Note that the recirculation rate for any RAS system is anywhere between 30 minutes to 1 hour.
So for RAS systems, one favorite common question I get from individuals is, how often do you exchange water? So I would say 0 to 20% is the typical rate of the volumetric exchange per day. Typically, it is very difficult to run at 0% water change, which also means that you do not change the water for a long time. Commercially, we have seen the lowest to be 3 to 5%, and we are running about 7 to 10% every day. It is not that we intentionally change out the water, but instead you sometimes lose water from the backwashing of the filters. So it is by operating the filters that you do lose water, irregardless of the filtration media that you will be using. So factoring into leaks that is definitely going to happen in your aquaculture systems. Sometimes that could account up to 9 to 10% of a volumetric losses during the backwash and leaks. And when you lose water in the aquaculture systems, you do have to replace them. So I would say a 9 to 10% is a conservative amount. So what are the pros of using recirculating systems? So I would first highlight the cons, especially pertaining to the mud crab industry. Number one, you definitely reduce the water requirements required for the mud crab aquaculture. You will be also farming them in a very intense manner, in a way that you will be stacking them vertically in boxes, and they are spread out over a very small floor area. Improved water quality can be true or false depending on your knowledge of operating a recirculating system. Waste capture better feed conversion and the isolation of products have also been known as pros for recirculating systems. We have also seen better inventory control when you are utilizing what we call recirculating systems with vertical farming, which we will explain in depth later on. However, there are also cons of using these systems for mud crab aquaculture. Number one is that it requires a high initial investment. It took us about $20,000 to get everything set up, and that includes of all transportational costs of equipment up to our doorstep, as well as the required civil works. On top of that, running an aquaculture plant will also result in a very short response time. What do we mean by short response time? It is the reaction time available for you to carry out any corrective action in the presence of an emergency, may it be power failure or some other form of emergency. As the RAS system is a life support for all the creatures inside, a failure, for example, like the pump, would always have a catastrophic result. Also, there have also been a lot of failures in using RAS systems. Another point of cons in using RAS system is the required economy of scale, as most systems would yield the benefit of having a volume. For example, in the softshell crab business, which also utilizes the same technology as the vertical farm, usually you would require scale of a minimum 5,000 boxes to be economical. Lastly, a lot of people profess to be experts, but they are usually not. So our advice from RAS Aquaculture is to weigh and judge every advice you receive with a pinch of salt and use your fundamentals to understand whether it is logical or not. How are recirculating systems used currently? So common uses for RAS systems are in the hatchery business, nursery, quarantine, fingerling production, purging of market-sized products. So what do you mean by purging? Purging of market-sized products could be anything between restaurant chains, aquariums that are located in restaurant chains that often purge the creature, whereas be crabs or shrimp, of their ammonia in their system, ensuring a better quality growing out system. A near market holding system is also possible to utilize with RAS. So, what are the common uses of RAS systems in the crab business? So we have previously seen that restaurants always like to store their crabs in their aquarium, so which is what we call purging of market-sized products, and near market-sized holding systems. So holding systems can be run on RAS systems, which increases the shelf lives of the crabs. And lastly, it also has been used for crab fattening and softshell crab, and also in some part of the world, grow-out operations. The RAS system is always designed based on how much you are feeding and not how much you are stocking. So do not be impressed by those who have claimed that their system can house up to 1,000 crab or 2,000 crabs. Be impressed if they can feed the crabs up to 3 to 5% body weight while still maintaining good water quality. Based on material balance, we know that for every kilo of feed we will be providing into the system, it requires 0.25 to 1 kilos of oxygen to process, and it also requires what we call alkalinity. It requires 0.18 to 0.4 kilos of alkalinity, and as a byproduct we produce 0.35 to 1.4 kilos of carbon dioxide, and we also produce waste, which is feces and uneaten feed, and most importantly we produce ammonia in the form of total ammonia nitrogen. And this is all from processing only 1 kilo of feed. Your RAS system design have to consider the 6 following points. Number 1, you have to worry about bacteria. So bacteria can be or pathogens in general, alright? And your system has to remove waste efficiently, and it has to convert ammonia to NO2 to NO3, and it has to remove CO2 while maintaining alkalinity and pH and adding oxygen. These 6 points are general for any RAS systems. However, for crabs, we only have to worry about the 4, which is pathogens in the form of bacteria and viruses, removing solid waste, converting ammonia to NO2 to NO3, while maintaining alkalinity and pH. This is the different unit processes that is typically found in the aquaculture systems for fish. We start off with the fish tanks, in which the fish are cultured in a circular tank, after which the water will flow through what we call a drum filter, which is what we call mechanical filtration, and it will then be disinfected with UV light and remove of ammonia using the biofiltration process. And lastly, it will go on to ozonation, which is also a form of disinfection and removing additional organic compounds. And lastly, we will remove the CO2 from the system, adding in back oxygen and flowing back to fish tanks. So these are the typical operations that you would see if you're visiting a salmon farm per se, trout farm, or maybe a sturgeon farm. Luckily for us, we utilize a simpler process flow diagram. Firstly, on the leftmost side, we have what we call the culture tanks, and these are the individual boxes in which the crabs are grown in. Followed by solid removal, which is the utilization of media filters to remove away any solids made that is resulting from feed or feces. The third part will be removal of ammonia, NO2 and NO3 using the biofiltration process, followed by disinfection. Since crabs can tolerate high CO2 and low oxygen levels, the water after disinfection will be recirculated back to the culture tanks and recycled. So that's all for now. In the next lecture, we will show you the importance of solid removal in the culture tanks and the solid removals in the media filter and different technologies that are employed for solid removal. So see you then.